Assalamualaikum and hi everyone. Today I'm going to discuss about tutorial 3 learning outcome 3.1. Now let's look at question number 3. Given that from the question the mass of the child is 12 kg, the initial velocity is 90 km per hour and the time is 0.05 second. Show that the violent force during the collision will tear the child from his arm. Give some comment. So the question minta kita cari F. Okay, we know already that we have three equations in this chapter, which is momentum equals to mass times velocity. Then we have the impulse equals to F delta T. And we have impulse equals to the change of momentum, which is mv minus mu. We can relate the impulse, which is F delta T, and the change of momentum to solve this question. So we have the impulse F delta T, and we will relate with the change of momentum. So we have F delta T equals to change of momentum, which is mv minus mu. Okay, then we can calculate the force, which is mv minus mu over delta T. Okay, so from the information given, the initial velocity is known in the SI unit. So means that we need to convert it into the SI unit. Okay, so U is 90 km per hour. We need to convert it into meter per second. So remember that kilometer to meter we need to times 3. Then hour to second we need to times 60 times 60, we have 25 meter per second. We substitute all the information given. Okay, we have mass, T, and also U. Okay, the mass is 12 kg, V is 0. Because V is 0 sebab dia apply the brakes, so jadi dia punya final velocity akan jadi 0. Then the initial velocity is 25. Okay, over delta T, which is 0.05. Then we get the answer is negative 6,000 Newton. Therefore, the magnitude of the needed retarding force is 6,000 Newton. Okay, and then we need to comment that a person cannot exert a force of this magnitude and the safety device should be used. Okay, so kalau kita dapati sekarang, okay, kenapa a person cannot exert a force of this magnitude? Because kita refer from the mass. Mass of the child hanyalah 12 kg. So bila kita darabkan dengan 9.81 ni, kita nak cari weight dia. So weight dia hanyalah 117.72. Okay, Newton. So di mana weight bagi child adalah terlalu kecil if we compare with the retarding force that exert to the child. Therefore, a safety device should be used to reduce the impact of the collision. Now, let's look at the question number 4. What portion of the graph represent the impulse? Okay, so impulse kita boleh dapati daripada area under the graph, which is, okay, so kita just tuliskan impulse equals to F darab dengan delta T, iaitu area below the FT graph. Okay, itu jawapannya. Okay, so untuk number 6, kita lihat a ball with mass 400 gram is moving horizontally with a speed of 13 meter per second. So this one is U. Hits a wall and rebound at 18 meter per second within 0.1 second. And so this one is velocity. So ingat rebound means that bola tu akan berpatah balik semula, iaitu of course lah in opposite direction. That's why kita kena ingat dia mestilah negative sign. And T is 0.1 second. Okay, calculate the impulse and the magnitude of the force by wall act to the ball. Okay, so to answer this question, kita nak kena cari the impulse. Okay, we use impulse equals to delta P, which is the change of momentum, iaitu mv minus mu. So m akan sama dengan v minus u. M is 400 gram, so convert to kilogram. V is negative 18 minus U is positive 13. So kita akan dapat jawapan negative 12.4 Newton second. This one is for the impulse. And then the magnitude of the force we can get from the formula of impulse equals to F delta T. So now from this formula, we can get the force, which is negative 12.4 over 0.1, and the force is negative 124 Newton. And direction is towards the ball, because we get the negative answer. Now, let's look at the question number 8. A baseball has mass 0.145 kilogram. Then the pitch ball has a magnitude of 25 meter per second, and the batter ball velocity is 55 meter per second in the opposite direction. Okay, let's say kita ada satu ball, okay, dan kita ada satu bat, dan velocity ni gerak dengan laju awal 25 meter per second, dan di apply semula, okay, after rebound, so dia akan jadi 55 meter per second in opposite direction. So katakanlah U kita yang negatif sebab arah dia ke kiri kan, okay, dan V kita akan jadi positif. So kita boleh cari the magnitude of the change in momentum of the ball, okay, by using the formula of delta P equals to mv minus mu. Okay, the change of momentum equals to mass V minus U. M is equals to 0.145. V is 55 minus U. U is negative 25. So we get the answer 11.6 kg meter per second. So kalau awak buat in opposite way, katakan U tu to the right and then V yang rebound, so awak akan dapat negative. So doesn't matter lah sebab dia nak cari just a magnitude sahaja. Okay. Then for B, if the ball in contact with the bat for 2 milliseconds, find the magnitude of the average force applied by the bat. So to answer this question, kita akan gunakan formula impulse equals to F delta T. Okay, so kita nak cari F, okay, impulse over delta T. Kita tahu that the change of momentum adalah sama dengan impulse. So, kita just masukkan 11.6 over delta T, which is 2 millisecond. Okay, convert to second. We get the answer 5,800 Newton. Okay, that's all for learning outcome 3.1. Thank you.